song to show you, a hand trick to show you. Okay, so let's start with this one, and if we break this up into increments of 30 degrees, and in one circle there's 360 degrees, how many equal parts would I have in this circle if I took a circle and broke it up into 30 degree increments? 360 degrees divided by 30 is 12 equal parts, right? So let's break this circle into roughly 12 equal parts, which means in each quadrant there may be 3 parts, right? So I'm going to say roughly like this. Like this. Have we done this before? Yeah, we have. My math 137 class, we done this like 5 times. When I was going over my notes yesterday, I was very conflicted on whether or not we had done this before. Because I don't think that was because we've got to get better at our radians, right? Like right now for most of us, when I give you a radian measure, you don't have any idea what that is in degrees. Maybe you don't even know like what it's in reference to. And so we've got to get better at that so that we're not always converting. And also that we're able to draw our angles in. That one on the quiz yesterday, that on the no calculator part, that said draw the angle in. A lot of people were in the wrong quadrant on that. And some people were in the right quadrant, but in the very wrong spot of that quadrant. And so we got to get better at that. So first of all, we're gonna do this with degrees, and then we're gonna talk about the different ingredients. So you're gonna write degrees and radians around this. So keep that in mind as you write it. I'm gonna write my degrees on the inside, and then I'm gonna write my radians on the outside. So this is 0 degrees. Up here is 90 degrees. 80 degrees. 70 degrees. And again, breaking 360 degrees into 12 equal parts tells you that each one of these is 30 degrees. And so this is 30 degrees, this is 60 degrees. Not a coincidence that the triangle I want you to memorize right now is a 30, 60, 90 triangle, because these are where our units are going. And so we're just going to count by 30 degrees. Okay, so I'm trusting that we can do that. So, 300, 330, and 360 gets me right back at me. Okay, so 360 degrees and 0 degrees or something. What we're probably not as comfortable with is doing the same thing in radians. So first of all, let's label our this is the X and the Y axis, our 0, 90, 180, 270. We feel pretty good about those.
All 7th graders last name A through E. Please report to the library to see the provided following.
0 radians. And what's over here at 180? How many radians are in 180 degrees? Pi radians. 90 degrees is pi half radians. So then down here at 270 is 3 pi half, right? Pi and a half. It's like 1 whole pi plus half pi, 1.5 pi, or 3 pi. So we can think about this 2 ways. One way is we could just kind of break it up and do the conversion, but the other way is just like with 360 degrees, we divided it into 12 parts. Into how much is each one? How much is radians all the way around again? So if I took 2 pi. So if I took 2 pi and I divided that into 12 equal parts, 2 pi divided by 12 means each one of those represents just like you can take 360 divided by 12 to get each one is 30 degrees. If you count by 30 degrees, in radians, you're just counting by 6. So I always say, like, I'm going to teach you to get better with fractions if you're bad at fractions, because we're going to go by fractions. So this 30 degrees is pi 6. And if we just count by 6, 2 pi 6, right? We're not going to write 2 pi over 6. We're going to reduce that. And 2 pi over 6 is really pi 6. And pi halves, isn't that just 3 pi over 6? 3 pi 6 is pi halves. So then what's this? How many pi 6 do I have? 4 pi 6, which reduces to 2 pi. And then, I always think of it this way, 1/6 away from pi. Like, right, this would be 6 pi 6, and what's 1 less than that? 5 pi. And then we can just keep going. So what's 1/6 half pi? 7 pi 6. That was yesterday's. I'm so bad. Because I was trying to make you do more work yesterday, but now I got it, right? Now you got it for the test. So then what would this one be? 8 pi 6, but 8 over 6 reduces to 4. Remember that this one's already counted, but that would be our 9 pi 6, because 9 over 6 reduces to 3 halves. So then what would this one be? 5 pi thirds, or 10 pi 6. And then 1/6 away from 2 pi would be 11 pi 6, because 12 pi 6 would be 2 pi. Right? So you can always just count by 6 if you're talking about 30 degrees or 60 degrees. Something else, and I won't mention this a lot right now, but I'll mention it later. Some people always notice that if you're going by 30 and 60 degrees, all the ones right above the x-axis are 6. So just kind of look at this. This is pi 6. Look over here. The one right above the x-axis is 5 pi 6. The one right below that is also a 6, 7 pi 6. And the one right below the x-axis is 11 pi 6. And then look at all the ones that are 1 away from the y-axis. Those are all your thirds. So you can kind of count those as, this is pi thirds, 2 pi thirds, this is like 3 pi thirds. But then 1 away from the y-axis is 4 pi thirds, and 5 pi thirds. Not that you have to do it that way, I think. But some people always think the thirds are together and then 6 thirds. And then the other special angles, I did a separate triangle because it gets kind of muddled if we put it all in one, is using 45 degree increments. So I'm going to do, if I break this up into 45 degree increments, this is 90 degree increments, right? So 45 would just be cutting each of these in half. So I could draw in roughly about halfway on each one of these. Again, we're labeling it, so back in the day, it's circular. If you have Mr. McClure for geometry class, just draw the shape. He used to draw his circles on the chalkboard in advance before kids came in, so that he could use them. I'm going to label all these, alright, in degrees. And honestly, this is where you're going to get at some point. For me, I struggle counting by degrees more than I struggle counting by radians, because radians is what we use all the time. So for me, I always have to think, okay, 90 plus 45, that would be 135 over here. 8, 225, if that makes sense. Right? And this would be 315. And then back to 316. I just don't use degrees on this, which is why I struggle with that one. in my radians that hopefully I'm getting better at. 0, pi halves, pi, I know it's kind of smushed there, 3 pi halves, and back to 2 pi. Increments of 45 degrees are just like over here. We can think about this. What is half of pi halves? Pi fourths. So counting by 45 degrees is just counting by fourths. And just like I did over there, you can just reduce it, right? 2 pi fourths is the same as pi halves. So this would be 3 pi fourths. And you can think about that. That's 3/4 of the way to pi. Because pi would be 4 pi fourths. The one past that would be 5 pi fourths. 1 and 1/4. 3 pi halves is the same as 6 pi fourths. So that means this one is 7 pi fourths. Because eventually, right, yesterday on the quiz, your only possible answers on the no calculated part were 30 degrees, 60 degrees, or 45 degrees. But after we learn about how we can go past the first quadrant, and after we learn the unit circle, on the no calculator part, your answer could be any of these, right? Any multiple of 30, 60, or just any multiple of 30, any multiple of 45 degrees. So we want to make sure we know where these angles are before we start getting to what is the unit circle and what are these values and how I do all that. And so this is not the last time that we'll draw this out, but hopefully the next time we do it, it'll be like easier for you. And so again, it's something that eventually you're going to be able to do it pretty easily. Right? We're taking baby steps. I don't think we actually get to the unit circle until on school Monday. Thursday, I don't think we actually get to the actual unit circle until Thursday next week, because we're just going to kind of like layer the steps in there that we need. All right? Okay. So that's the special angle stuff. The majority of what we're going to do today is going to be just SOHCAHTOA applied to past the first quadrant. And so instead of talking about that we have this cute little right triangle, and we're talking about those acute angles, we can talk about theta is any angle in standard position with xy on the terminal ray. So let's draw in, we'll do it in the first quadrant this time so we don't have to think about positive and negative. But if we just drew in an angle in quadrant 1, we can draw that theta. This is, instead of thinking of it as opposite and hypotenuse and adjacent, we can relate this to the ordered pair that would be on this ray. So it says theta is an angle in standard position with some point xy on the terminal ray. So on my terminal ray, I'm just going to make points, and I'm going to call that x. And we can write out all of our trig functions using x and y instead of just using opposite over hypotenuse. So just think about if I connected this point down, if I drew in like a little dotted line, you agree that that's always going to make a right triangle? Always. So if it helps you to draw a picture, you can draw it. Because the length here, wouldn't the length of this from that point to the x-axis, would that always be the length y? So that's the point xy, so that's going to be here up y. And the length of that triangle, the adjacent side of that triangle, is always going to be x units, because you're over at x on the x-axis, so that's just going to be x units. And the hypotenuse is still the hypotenuse, but we want to start thinking about this as the radius of a circle. So notice they call it r. We're going to call this r, because the idea is, what if we use this point to make a radius and we connected it around, so we made a circle? That's where the r comes from. You can find r just like you found the hypotenuse on the quiz yesterday. It's just Pythagorean theorem. Does that look like Pythagorean theorem? Kind of, right? They just went ahead and solved for r. So instead of saying r squared equals x squared plus y squared, They just went ahead and solved for r, so they just took the square root of both sides. So r will always equal the square root of x squared plus y squared, and r can equal 0. Also, r can't be negative, which is why we treat it with a negative 1. So, geometry, you learned SOHCAHTOA. Precalculus, trig, we want to talk about this in terms of x's and y's. So sine, instead of saying opposite over hypotenuse, we want to start thinking about if we have an ordered pair, the sine, the opposite side will always be the y coordinate, and the hypotenuse will always be the radius of that circle. If you draw the picture, you can still think about opposite over hypotenuse. But the idea is that at some point we're not going to draw something. And so we could go ahead and throw over here the cosecant. We could just flip it around, right? Cosecant is still the reciprocal. So that's going to be r over y. But we need to say that y can't equal 0. Because if y equals 0, we have a problem. It's undefined. We don't have to say that for sine because r can't equal 0. So sine will never be undefined. Cosine. The cosine of this angle will always be adjacent over hypotenuse, but in the coordinate plane, that will always be the x-coordinate over r. Which makes secant r over x, where x cannot equal 0. So again, secant can be undefined, cosine can't be undefined. Cosine is a nice continuous function, always defined. And tangent, I don't even need r for tangent, right? Tangent is opposite over adjacent, or in our coordinate plane will be y over x. We do need to say where x can't equal 0. And our cotangent is x over y, where y cannot equal 0. Which means 4 of our 6 trig functions can be undefined when you have certain values on them. Something else to think about is depending on what quadrant you're in, sine, cosine, tangent, all of them, they might be negative as well, because up until this point, everything's always been positive because we've been in the first quadrant, we've been looking at right triangles, but when I extend that to other quadrants, these can be negative values too, because if x is negative, that's the intersection of the talk about that today. Right, so let's look at examples so I can show you what we can do with this. So I'm going to attempt to do this without a picture first, and then I'm going to show you that we can draw a picture every time to help you, but I just want to show you kind of the idea of why we would want to do this over SOHCAHTOA. 1, we can go past the quadrant, but 2, if they give me a point, I don't have to have a triangle if I know those ratios, because this is just my x, and this is just my y. And can I solve for r if I just know x and y? Because r every time is going to equal the square root of x squared plus y squared. So in this one, that's going to be 144 plus 25, which is the square root of 169. Let's see, what's that going to be? Which means if you know x and you know y and you know r, you don't have to look at your triangle anymore. You don't have to think about it if you know those ratios. So we said sine every time is going to be y over r. So I just can say that the sine of this angle equals y, which is 5, over r, which is 3. Same kind of answers I got when I was doing the right triangle stuff, but now we've kind of taken it beyond. So cosine is always x over r. So my x value in this one is negative 12. So that means that my cosine value is negative 12 over 15. The first time we've ever got a negative value, except for maybe this x. And tangent is just y over x. So we could say 5 over negative 12. Negative 5 over 12 is the same answer though, right? So if you just had tangent, you might not know which one was negative, because it doesn't have the right negative sign. We could do the other three also. I just figured if you want to just flip them over. If it helps you, draw it out, right? So just really quickly, I'm not going to actually label it negative. I'm just going to mark it over here and say this is 12. And let's put 5. So you made the point of the terminal side of your angle, right? So my angle will start here, and go out like here, right? The triangle that's formed, you always have to draw that triangle with the x-axis. So if I like drew in my dotted line, this is the triangle that it makes, and this is always your theta from the origin. So we're actually, like, we're measuring the angle from here over to here. But this would be the triangle you would use. So notice that my opposite side is 5, my adjacent side is negative 12, my hypotenuse is 13. So if it helps you to draw the picture, draw the picture. But the idea is you don't have to draw a picture of a triangle anymore if you know sine, whatever, or okay, I really only got one more thing. What if we look at which quadrant are which trig function going to be positive and negative? And I'm not giving you this thing on the next slide as something that you can memorize. I just want you to see kind of a pattern, and I want you to see how you can figure it out on your own on a test. So, sine of trig function is kind of tricky to say because we're going to talk about sine as well. What we're going to do is for each quadrant, we're going to look at the sign of sine, cosine, and tangent. So for each one of these, each quadrant, I'm going to write sine, cosine, tangent. Based on what we learned today, since sine of an angle is always y over r, cosine of the angle is x over r, and tangent of the theta is y over x. If you know whether x and y are positive or negative, you can tell me whether the trig functions are positive or negative. I didn't put the other three up here, because if I know the sign of sine, do I know the sign of cosecant? Right, like the reciprocal functions are the same because you're just flipping them over, so I don't feel a need to do that. So in quadrant 1, if I thought about my x and my y, in quadrant 1, do you agree that x is always positive and y is always positive? Which is why in geometry class, when you did your trig chapter, you only dealt with right triangles. That means you only dealt with the first quadrant. Which is why everything's positive. Because if y is positive, this is going to be positive. If x is positive, it's going to be positive. If they're both positive, it's going to be positive. Right? So in quadrant 1, everything's positive. Because remember, r can't be negative. R is the hypotenuse. You do the square root. It's a length. It's always a positive number. So r really has no effect. What about in quadrant 2? In quadrant 2, if I talk about my ordered pair, what would you say? X coordinate in quadrant 2 positive or negative? It's negative because I'm over here, right? And up here on the y-axis, I'm still positive. So based on that, is sine going to be positive or negative? The sine is y, and y is still positive, so sine is positive. What about cosine? Like our example we just did, right? It's negative now, because if x is negative, then x over r is always going to be negative. And what about tangent? Y over x. If one's positive and one's negative, it's also going to be negative. What about in quadrant 3? My ordered pair for x and y in quadrant 3 is negative, right? X is negative and y is negative. Which one would be positive? But sine is just y over r, right? So r is always positive, but y is negative. So sine is going to be negative. What about cosine? Still negative. But what about tangent on this one? tangent's going to be positive because a negative over a negative is a positive number. And we're going to keep going here. And again, I'm never going to ask you to repeat this. I just wanted to kind of show you how you can think through this. In quadrant 4, I'm over here on the x-axis, so x is positive, but y is negative. So now sine, y is negative, so sine is negative. Cosine is x, and cosine, x is positive, so cosine is positive. And now that I'm back to different signs, one is positive, one is negative, tangent is also negative. Kind of something interesting to point out that we're going to talk about later as we talk about graphing these and as we talk about solving equations with these. Every trig function is positive in 2 quadrants and negative in 2 quadrants. So sine is positive in 1 and 2. Cosine is positive in 1 and 4. Tangent is positive in 1 and 3. That's going to come into play over and over again as we solve equations, as we graph these equations, kind of see how they repeat themselves. As we do the unit circle, you're going to see the values repeat themselves. We're just changing signs, positive and negative, as we go around those special angles. So today, all we're doing with it is trying to look at that pattern, and then the next page here, it says determine the sign, whether positive or negative, of these angles without using a calculator. Right? Because you can always type that in your calculator, and it'll give you the decimal positive or negative, which means on a test, I would be using on a no calculator portion. Degree part's really easy, right? Hopefully the radian part will be easier today after our little shortcut I showed you. But all you have to do is figure out what quadrant is this angle in, and then figure out whether it would be positive or negative. So step 1, 299 degrees. What quadrant is that? Quadrant 4, right? Because this is 270 degrees. So this is in quadrant 4. So then you just have to think about what's the ratio for cosine, and is x or y positive or negative depending on what is there, okay? So again, no calculator part of my test. You don't necessarily have to show me a lot of work, but I'm just going to kind of show you my thinking as I go through this. So for me, cosine, I think about cosine in x over r. So I think about in quadrant 4, the x coordinate is positive, which means that the cosine of 299 degrees is positive. I don't care what the value is, I just want to know whether it's positive. So the idea now is, can I figure out where 2 pi thirds is without converting it to degrees, right? You always have that option, but I want to really encourage you to not do that every time. And so based on what we did today, or maybe based on just that you know that this is pi, where's 2 pi thirds? Quadrant 2, right? Because like this is pi halves. You just think about 2/3 is in between 1/2 and 1. That makes sense. But 2 pi thirds we learned today is like right up here. So this is in quadrant 2. So is tangent going to be positive or negative? Because in quadrant 2, x and y are different signs, so that's going to be negative. Right? So again, not a lot of work to write down, but just kind of putting all the things together is what we're looking for today. Right? So that's it. That's all which means you're just doing 3 through 12 multiples of 3. I think are using the new x over r, y over r stuff. And then 17 through 20, I think, are like the last one. Yeah, 3, 6, 9, 12, they give you a point. 3 and 6, they give you a picture. And then at 9 to 12, a little more thinking involved because they're giving you a point on the x or y axis, which is don't find both of those. You can use ratios on those. And then 17 through 20 are just give the answer positive or negative is all we're looking for there on those. So you actually have some time to work that you can get started on those.